Lesson 68. This is a lesson on antidifferentiation, which is the opposite of differentiation. In these questions, you notice you're given the function which is the derivative of what you're looking for. Let's say we are given a function f of x and we want to find y such that f of x is equal to dy by dx. Let's take 2x as dy by dx. Find y. We remember that 2x is basically the derivative of the function x to the power of 2. But is this the only possible answer if you think about this? What if there's a constant in the function, like y equals x squared plus c? Well, if you take a derivative of any constant c, we get 0. So in a sense, when we think about the antidifferentiation of dy by dx equals to 2x, you're considering a family of function where any constant that belongs to real numbers can be added to x squared. Sometimes you notice the notation of f prime of x, and we say that if dy by dx is equal to f prime of x, then after antidifferentiation, you will get y equals to f of x plus c, and c is a real number. Okay. And this is the antiderivative of f prime. The set of all antiderivatives of a function h of x is also known as the indefinite integral of h of x. So let's take a look at some notations here. This is the integral sign. The function h of x is the integrand, and the part where it shows that x is the variable of integration. In other words, we can consider the derivative of the integral of h of x as h of x itself. So basically d by dx and the integral, they can be thought of, they are undoing each other. Okay. However, when you take the integral of the derivative of f of x, you will get f of x plus c. So the plus c, the constant, is very important here. Now let us consider some antidifferentiation questions. Example 1. Find the antiderivative of x cubed. Using formal notation, we can write this as the integral of x cubed dx. When you go backwards of taking derivatives, the exponent should go up by 1 instead of going down by 1. So let's start by writing x to the power of 4. In your head, try to take the derivative of x to the power of 4. It gives you 4x cubed, which sort of matches x cubed with the extra coefficient of 4, which means now we have to divide this by 4 and then plus c, the constant. B. Antidifferentiate 5x to the power of 4. We can use the integral symbol of 5x to the power of 4 dx. Start with x to the power of 4. When we take the antiderivative, the exponent goes up by 1, and then we divide that by the same exponent, which is 5. But my original question actually had a 5 in it. And then plus c. You can simplify the 5s and get x to the power of 5 plus c as a result. Question C. We will take the integral of the square root of x by dx. Now you can consider the square root of x as x to the power of 1 over 2 to make it easier. What do you think your answer is going to be? Once again, x to the power of 1 plus 1/2 divided by the same exponent, which is 2/3 plus c. The chart below shows that when you're taking the integral of x to the power of n, the exponent of n goes up by 1, and you divide the whole expression by n plus 1, plus the constant at the end. If you have a scalar multiple of x to the power of n, the scalar multiple is k, you can pull it outside of the integral and then multiply that to the final expression after. Very similar to how you can take the derivative of a function or calculating limits. When you are dealing with an integral of a polynomial or a composite function of multiple functions being added together, you can take the individual integrals of each function and then combine them together using plus or minuses. Again, very similar to the rules that we know when we find derivatives. Question 2. Find the indefinite integral of each. First, let's start with the indefinite integral of 4x to the power of -3. Give it a try yourself. You can pause the video. Have you tried this question? Let's check your answer. X to the power of -3 plus 1, so now it's -2. I'm keeping that 4 as the multiplier, but now I have to divide by the same exponent, plus c. This simplifies into -2 over x squared plus c. How about the next question, B? I can first rewrite the two parts of this monomial separately. So I'm going to leave the coefficient of the 6th root of 3 outside of my integral symbol. And then I have the 6th root of x squared. I can turn this into x to the power of 2 over 6 or 1/3 dx. And then find the integral of that. So x to the power of 1/3 plus 1 is 4/3. I have to divide by 4/3, which turns into multiplying by 3/4 plus c. So this is going to be 3 to the power of 6 times 3 inside the 6th root. It's a little messy, but this will do. Example 3. Find the following integrals. You can pause the video again. Try these questions. You may have to consider how you can manipulate these original expressions before you take the integral. Come back to this video when you're done. Okay, let's take this up. 3a. We can integrate this trinomial term by term. Starting from the first term, I have 3x to the power of 3 over 3 minus 2x to the power of 2 over 2 plus 6x plus c. If you think backwards using this line, when you take the derivative of this line, does it give you 3x squared minus 2x plus 6? And then let's simplify this further. Here is your final answer. Question B. Here I have a binomial multiplied by a binomial. It doesn't look like a polynomial. Experience from taking derivative of functions told us that the expanded form is easier to work with. So let's expand x plus 6 times x minus 2. I get x squared plus 4x minus 12 dx. So now I have x cubed over 3 plus 4x squared over 2 minus 12x plus c, where I should reduce the second term. Plus 2x squared minus 12x plus c. Question C. Here we have the integral of a quotient of two functions. The good news is the denominator is a monomial, which allows me to divide every single term in the trinomial by x squared. This way, I will get a simpler trinomial when I take the integral. And I will write 2 over x squared as 2x to the power of negative 2. Let's take the integral. X to the power of 4 over 4 minus 4x squared over 2, so this is 2x squared. When I look at x to the power of negative 2, when I add the exponent by 1, I get an exponent of negative 1. I have to divide the term by negative 1. This turns into plus 2 over x plus c. Okay, let's consider the antiderivatives of primary trig functions. So once again, we're thinking backwards. What do you think the derivative of cosine x dx would be? So when you take the derivative of this function, you get positive cosine x. That's right, it's sine x plus c. Next, when you take the derivative of this function, you will get positive sine x. Think carefully. Did you say negative cosine x plus c? And finally, when I take the derivative of this function, I get the square of secant x. What is it? It's tangent x plus c. Now let's use these rules to help us answer the following questions. Starting with the integral of pi over 4 times sine x plus cos x dx. Notice pi over 4 is a constant multiple, so we can pull it out. We are just taking the integral of sine x plus cos x dx. As a result, I have pi over 4 times the integral of sine x is negative cos x, plus the integral of cos x is sine x plus c. Question B. I have the integral of sine 2x over cos x dx. Sine 2x, I can't just say the answer is going to be negative cos 2x because it's a composite function. However, I can simplify this expression if I first write sine 2x as 2 sine x cos x over cos x dx. See how useful trig identities are? Now I can cross out cos x, and I know the answer of the integral of 2 sine x is 2 times negative cosine x. So I'm going to write this as negative 2 cos x plus c. Let's move on to example 5. Find f of x given f prime of x is 3x squared plus 2x. The curve of f of x passes through 1 and 7. We know that the relationship between f of x and f prime of x is that f of x is the antiderivative of f prime. So let's write this down. As a result, I'm taking the integral of 3x squared plus 2x dx, which allows me to find 3x cubed over 3, which is x cubed. And then the integral of 2x is 2x to the power of 2 divided by 2, which is just x squared plus c. So this is just a generic family of function with a constant. However, we are told that the graph of f of x passes through the point 1 and 7. With that piece of information, I can actually calculate the constant c by substituting 1 as x and 7 as the y value. Like that. I have 7 equals to 2 plus c, which means that c must be 5. And therefore, the particular function f of x that I'm looking for is x cubed plus x squared plus 5.